And so I wanted to introduce our speaker. We have Boyd Roloff with us tonight, and he will be sharing some of his story as well as a lot of information. And I just from the brief times that we have talked, I know that it will be accessible, even though it is also detailed and coming from all that he has explored through this as well. So let's open in prayer, and then I'll turn it over to him. Lord God, I thank you for tonight. I thank you that we can look at the creation around us and that we can understand you on a deeper level than we could before. And I thank you that we have so many things to explore around us and for your word to constantly reveal more of who you are as we look at that as well. And I pray that as we come tonight to look at all of this together, that you would help us to continue to understand more about your creation, more about who you are, and more of what a difference that needs to make in our lives every day. Thank you for your love for us, Lord God. In Jesus' name, amen. All right.
Amen. All right. Well, I want to thank the church, Aaron, and Aaron was very helpful in getting me set up here. Thank you guys for inviting me down here. This is something that's been very dear on my heart for years and years, probably a good 10, 15 years, this whole evolution creation topic. And one of the items that really sets on my heart is that there's so much data out there. How do you interpret the data? And so that's what I'm going to be really talking about a lot tonight. But before I get into interpreting the data, question I've got is, you might want to know, who am I? All right. Well, that's a question I'd even like to ask you guys. There we go. I had to see if we're going. There we go. There we go. Question that somebody might come up to you and ask you, who are you? Who are you? What's your answer? My answer I like to give is, I'm a disciple of Jesus Christ. I accepted him back at around 1992. What does it mean to be a disciple? It's like being a student of Jesus, trying to learn. It doesn't mean I know how. I'm not walking like Jesus right now, but I'm a student. Or more accurately, today, it's even apprentice. If you want to be a disciple, you're being an apprentice of Jesus. So you're kind of trying to come alongside of him. You're learning how he prays, how he walks, and try to live that kind of a life. Besides being a disciple, I happen to also be a husband and been married for 36 years. My wife is right back there. And on this picture here, you can see she's sitting on her favorite animal. It's a turtle or tortoise. And then about 5 years ago, we were on our 30th anniversary. We were in Costa Rica, and she's standing next to the tree that happens to produce the item that is used for my favorite food item. Any guesses what kind of tree that could be? Coffee's a good guess, but nope. I actually don't drink coffee or caffeine much. What's that? Wow, you know the name. You know the name. It's a cacao. And actually sitting right at the, I can't quite see that there. There's a little ball thing sitting right at the thing. That's actually what holds the little beans that are inside of it. And it's used for chocolate, basically. That's how you make your chocolate, come from the cacao tree, the beans that come from there. So anyway, moving on, I happen to also be a father. I've got 3 kids. My eldest son, Zach, he happens to be standing in front of the ark. And then I've got son Aaron and my daughter, Rosa. I happen to also be a graduate. I graduated with a zoology degree from Madison and a statistical degree from Madison. And I also have an MDiv from Trinity. And that happened, oh, if you saw it there, that happened to have been my favorite animal too, koala bear. All right. Okay. So anyway, I happen to be associate director of statistical programming. I don't know if that means anything to anyone. I could also tell you that I have oversight over biometrics for pharmaceutical companies. I don't know if that means anything to anybody. But what it really means is that I oversee the processing of data for pharmaceutical companies. Just to back you up, for clinical trials, you might ask, how does a drug get to market? You have to run studies. So you have some chemical compound, you bring it into studies, eventually you move it on to human studies. So you give it to humans, you're trying to determine, does it work? We call it efficacious, and is it safe? So you run these studies, they're done at the places called clinics, and they collect data. That data gets put into a database, that database gets processed. And by processing, it gets summarized into tables, analysis gets done on it, and then that gets put into reports that get sent to various agencies in United States, such as, or around the world, really, FDA, EMA over in Europe, other areas. And so what I do, I oversee the processing of the data that summarizes it for the reports. In a nutshell, all right? And some of the therapeutic areas I've worked over is oncology, cardiovascular, Alzheimer's, infectious diseases. Probably the last 15 years, oncology, or cancer, for those who don't know what oncology is what I've been specializing in. So one of my favorite verses coming up when we talk about this whole topic of evolution is here in 2 Peter 3, 5, and 6. It's a prophecy. And Jesus has laid a prophecy to Peter to write this down. And it's very fascinating because in this prophecy, he's stating, most importantly, I want to remind you that in the last days, scoffers will come, mocking the truth and following their own desires. They deliberately forget that God made the heavens long ago by the word of his command, and he brought the earth out from the water and surrounded it with water. Then he used the water to destroy the ancient world with a mighty flood. Do people believe that today? Or are there a lot of scoffers who make fun of people who believe that? What Peter has here quoted as a prophecy. We're living in a day now where this is really true. So, for tonight, I'm going to be covering a few topics. I'll have an introduction of a few items. I will be going over the word day, which is otherwise in Hebrew called Yam. Big Bang, flood, fossils, arc, dinosaurs, geology, human evolution, and DNA, all tonight in the next 50 minutes, which means no, I'm not going to be spending a lot of time on each and every one of those topics. Each and every one of those topics I could spend an hour on by itself. So I'm going to try to give you the basics of it and keep things moving right along. So with that being said, paradigms. I want to go into paradigms. And so as far as the age of the earth, now we're not talking the universe, we're talking about the earth, was formed about 4.5 billion years ago, at least by one paradigm, which would be the evolutionists. All right. And so, and then you've got on the other side, 6,000 years. So we got a span from 6,000 years to 4.5 billion years to say people's views of when the earth was formed. Now, the people at the 4.5 billion years ago, we can classify them as macroevolutionists, and I am using that term purposely. Then there's also theistic evolutionists. Those would be a group of people that believe that the earth could have been produced 4.5 billion years ago, but they believe in God, and God did it. Many people believe in that. Then there's people called intelligent design believers. And that can be a whole group of people, anyone who believes. You look at nature, you look at biology, and you say there was an intelligent designer that must have been involved, such as God. All right? And so, but to be an intelligent designer, you could be what I consider old earth. You could be a theistic evolutionist, or you could be a creationist. So you can span any time span and still be an intelligent design believer, all right? And so, and then there's the creationist. And even in the realm of creationists, there's old earth creationists, young earth creationists. What I mean to say is there are people that believe that the earth was created 6,000, 6,500 years ago. There are some people that might say the earth was created 1,000,000 years ago, 100,000 years ago. And some of this has to do with various things called like gap theory. How long was Adam and Eve in the Garden of Eden? Were the genealogies truly father, son, or were there giant gaps between the fathers and sons that weren't reported? There's many, again, we could go on a lot of these items by themselves and how that all works, but just to say there is a range. And so with that, that's the paradigms we live in. These are the thinkings we have when we talk about evolution and creation. And so, a matter of interpretation. And so, we all have the same data to look at. We look around us, we have intelligent people on all views. And everyone views the data with their own biases. So I just want to be clear. We all have biases, all right? And so what do I mean by biases? Biases, what I'm saying is that you may be influenced by your teachers. You may be influenced by your friends. You may be influenced by parents, by video games, from social media, movies. All these things around you that you read, absorb, build how you view the world and how you respond to people. Now, saying that, so we all have biases. Does that mean our biases are bad? Not necessarily. Bias can be good. And for instance, a faith in Jesus is a good bias, all right? And so it isn't necessarily just a bad thing. But we, for our purposes here, realize everybody has their biases. And they're going to come into any kind of a discussion with their biases. So my journey. In my pre-college days, I consider myself an agnostic atheist. All right. Then I went into college and I worked on my zoology degree, which meant I learned all about evolution. And so I was a macroevolutionist. Then I became a Christian. And becoming a Christian, actually, I didn't really put the two together so much, but in reality, I was really pretty much a theistic evolutionist. I kind of believe in God and I kind of believed in evolution. All right. Well, then somebody came along and exposed me to some creation materials. Well, actually, before that, actually, I ran across some books on intelligent design. And so I became very much believed and followed into intelligent design. Anybody from the biology area, you look at biology, I honestly don't see how you can say things happen by pure chance, right? You must have a designer. So from there, I went on to become an old earth creationist, believing in the gap. So that's why I know a little bit about the gap theories and stuff. And the books I read, I kind of bought into that. As I read more and more information, I have now become a young earth creationist. And so you see my time span has started way out there, and it's come smaller and smaller as I try to remove my biases and just look at the data and see what the data says. Now, that's my opinion. You know, each of you can go on your own exploration. My whole story towards creation has started here. It's a tree stump. And so somebody about 15 years ago was presenting like I'm presenting here, and they mentioned around the world, you see tree stumps that are going upright, and they are sitting there through multiple layers of strata. By evolutionary standards, this could be hundreds of thousands of years that these tree stumps are sitting there. You've been in the woods. Do you see tree stumps that stay very easily? And can you even imagine hundreds of thousands of years? When that was presented to me, it's like, this did not make logical sense. So that suddenly opened the door to me to say, hey, I need to look at other information that's out there. And so that started my whole journey as far as onto creation itself. So, to evolution. What comes to your mind when you hear the word evolution? Most people, this is what comes to mind. You think about the Big Bang, all right? And from a Big Bang, you've got, as is shown here, somewhere, somehow, a bang occurs, and then you get a goo that gets formed, that's sitting out there. And then from the goo, you go into a cell, right? And then from a cell, you can continue. From the cell, it moves on into a plant. And then it moves on into animal forms. And then from animal forms, we move on to humans. When we talk about, isn't that a lovely person there, by the way? So when we speak of evolution, that's what most people draw in their mind, all right? And so for tonight, when you think about the word evolution, what does it mean? It actually just means change. So we want to keep that in mind, and that's why I bring up the term macroevolution versus evolution, and everybody just kind of merges those two terms together, and I'll try to correct that with you today. For instance, these dog species, they're all different. It shows change. And then moving on, you could go into finches. These finches show change. Is that all part of evolution? It's showing change. But these can be explained genetically. And so genetic changes, there's nothing wrong. It's a solid known type of change we can accept. And I want to distinguish that kind of change, which can be explained, from what's called macroevolution. All right? And so macroevolution, again, I'm saying Big Bang, a cell, and a human. Another terminology I like to keep straight is science itself. There's experimental science, and there's historical science. Okay? And people blur this together. And so to distinguish, experimental science is the stuff you see with experiments that are repeated. This is the same kind of science that will produce, for instance, genetically engineered cows, as well as the various tech that we see around today. Any tech, all right? This all comes from repeated experiments. This is solid. We understand it. Now we're going to step into the other side of things, historical science. Historical science looks at all the data that we have existing today, and we try to explain the past. So just to distinguish, you cannot repeat this. So you're really stepping into the realm of trying to explain based on what you see. And how do you do that with the various biases that you have? Again, people can come into this with their own biases and their own views. And so the data that we have are the galaxy, for instance. And you've got also fossils, for instance. And you've got strata layers of geology that you can look at. And there's microbiology that we can look at. And so all those things are part of data that we can collect. And so what's important when you're looking at historical science is, again, we all had the same information to look at. We all have the same information. However, it's a matter of how you interpret that data that you're looking at. Now, out there are people called atheists. This happens to be Richard Dawkins, probably the most well-known atheist of today. He does not believe in God. He doesn't want God in his world. And more importantly, he doesn't even want God in your world. So he is going to try to prove to you guys that God doesn't exist. And so what does that all mean? Well, let's look at it from a creationist. I don't know who that guy is. From a creationist, what does it mean to be creationist? First off, in your public school systems, in your public universities, you cannot teach about Jesus or creation very easily. As you are aware, on a university setting, you will get fired. In public schools, many cases, you'll get fired as well. You guys are all aware of that. Not only is it about teaching, what about publications? Most of your major publications, you cannot present information on creation. You may wonder why don't we see stuff published? Because you can't get it published anywhere. So that's why you don't see things on creation. And likewise, there's movies. You cannot, at Hollywood, get a really good, solid movie done on creation, or for the Bible, too. I don't know if anybody's seen the Emma Watson Noah, but that doesn't have, I think they got the name Noah right. I don't know of any other facts on that movie that were accurate. But anyway. All right, so let's look at Yom, day. In Genesis, you had this little formula going, and it's interesting. For 6 verses, you have this, and there was evening, and there was morning, the first day. Second day, third day, fourth day, fifth day, sixth day. You have that formula going. And then elsewhere in the Bible, such as in Exodus, they'll use days such as, for in 6 days, the Lord made the heavens and the earth, the sea, and all that is in them. So when we look at Yom, or day, it can have these general meanings on there. A general or vague concept of time, a period of a year, a period of light and day and night cycle, a period of 24 hours, or a specific point in time. All right? So in your Bibles, day can mean all that. But let's look at it outside of Genesis. When day is used outside of Genesis, and you've got day used plus a number, is used 410 times, and it always means ordinary day. Evening and morning together without day is used 28 times and always means ordinary day. Evening or morning with day is used 23 times, always means an ordinary day. And finally, night with day is used 52 times, always means an ordinary day. In other words, as it's being used here in Genesis, it seems to always indicate a day. And that was outside of Genesis. Now, why do people want to make a change when you're in Genesis? Maybe it's because they've got their biases. Morris here states it very succinctly as he's looked it over. The terms evening and morning each occur more than 100 times in the Old Testament and always have the literal meaning. That is, the termination of the daily period of light and the termination of the daily period of darkness, respectively. Similarly, the occurrence of day modified by a numeral is a construction occurring more than 100 times in the Pentateuch. That's the first 5 books of the Bible. It always means literal meaning. Okay, so again, day very typically means a 24-hour period. So, what does the data actually tell us? I'm going to do a little demonstration first. And I call this the little bang. Not to compare to the big bang. I got a bag. It's got air inside of it. It causes a bang. All right, that's what I call the little bang. All right, you are awake now, right? All right, but I want to point out a few things from this simple demonstration. What is involved in this demonstration? First, I needed a bag and air. I needed matter. The bag needed to be inflated. The air in the bag needed to be sealed. And finally, most importantly, a force needed to be applied for the bang to take place. If that force wasn't brought in, the bang would not occur. All right, so as far as the Big Bang's theory goes, where did everything come from? Conservation of mass tells us that in a controlled system, mass is neither created or destroyed. So where did everything come from? Evolutionists don't have a solid answer here. All right, we have an answer. It's in Genesis 1. God spoke and everything was created. Also, as with my demonstration, what caused the bang? When the Big Bang started, something had to cause it to start. Newton's law of motion tells us anything at rest stays at rest unless acted upon by another force. Or anything in motion stays in motion unless acted upon by a force. That's Newton's laws, all right? So what caused the bang? We've got an answer. God spoke, and the universe was created. Spiral galaxies, interesting. They were supposed to have been formed 10 billion years ago. How do they exist today? What I'm talking about is they're spiraling and they're unwinding. And they're unwinding at a pace that billions and billions of years, they shouldn't be in existence today. We know in Genesis 1, day 4, God spoke and the stars were placed in the universe. Evolutionists, check this out. They claim dark matter keeps the galaxy from spinning apart. They recognize that there is a problem here. They actually acknowledge this, but they've come up with something called dark matter. I was at a couple of the museums and this was posted there, and I kid you not. Something called dark matter accounts for about 1/4 of the universe's total mass. I don't know how they even derive that number. I'm not sure. It's mixed in with visible matter, but we can't see it because it doesn't interact with light, so how do we know it exists? Scientists noted that the rotating galaxies lack the matter to stay together. Dark matter describes the source of the gravity and keeps galaxies from flying apart. I kid you not. They had a problem, and their answer is dark matter. That's for the evolutionists, all right? Many questions about dark matter still remain unanswered today. And I've been in museums, by the way, and you watch people come in and read this, and they go, wow, that's it. That's it. Guys, don't check your brains out when you're here, you know? Use a little logic. What are they truly saying? So, solar system itself, I could spend an hour again going over each and every one of the planets and telling you that there are issues on how they got placed where they are today, and items with them. Don't know if you're aware, Venus spins backwards from the other planets. Why and how does that happen? Are you aware Saturn's rings are on a decay? I believe they can't get beyond like 100,000 years for those rings to still be there. How do you get that back to 4.5 billion years ago to form? There are each and every one of the planets and their moons have many challenges. I'll just call it challenges. To me, I got an easy explanation. It's called God, you know. But they've got many challenges to say how these were formed naturally or by some evolutionary model. Now, when we get into Genesis, in the Christian realm, many people have kicked around Genesis. Is it myth or is it history? What I'm saying is many people have bought into the myth model, right? And what I'm saying is they don't believe Genesis 1 through 11, that's up through Abraham. They believe that was just a myth written for Moses's and Israelites' benefit, our benefit. They do not believe even the flood occurred. All right. My question is, if there was truly a flood, is there any evidence? Interestingly, there's hundreds of cultures around the world that have a flood story in their background. Why do you think that might happen? Maybe because it was part of their past. If there was a flood, what would you expect to see? And for those who have been at the Ark, you might have ran across this statement, famous statement from Ken Ham. You would expect to see billions of dead things buried in rock layers laid down by water all over the world. What do you see? Billions of dead things buried in rock layers laid down by water all around the world. Interesting, right? Fossils. Have you ever thought about how hard it is to create a fossil? You have something that dies. Why don't you see it fossilized? Because they decay. Animals eat them. It is very, very hard to get something preserved. What you need to do is maybe have something happen very quickly, such as a bug trapped in sap, a mammoth buried in a blizzard, or a flood. Those are easy explanations for fossils. A dinosaur that dies and just is laying and waiting for strata layers to fall on top of it, it's going to get deteriorated and destroyed. You're not going to get the nice, neat fossil bones. That's what you find unburied. What else should we expect to see? Signs of rapid burial. Do we see signs of rapid burial? If we look at the fossil record, well, a fish eating a fish. Think that could have taken a couple hundred years to bury? That had to happen very, very quickly. Also, here is a fossil that's giving birth. Now, the women here, I would hate to think about a birth lasting 100 years or something, but this had to happen. The burial of this fossil had to happen very, very quickly. There's many, many examples like that. Interestingly as well, is many fossils are found in what's called the gasping for air or drowning pose. Now, would that occur if you were just laying down on the ground dying? Again, if you're gasping for air and dirt and sediments are coming around you, that would be explainable. Another item is fine detail. This dragonfly, for instance, how do you preserve those wings? If you're saying out in nature, it dies. It's laying there and it gets fossilized. Wings will break apart very, very quickly. And so again, if a mud comes over it, it can cover it and preserve it. A flood model, again, is a good explanation. Details on this leaf. You might say, oh, big deal, big deal. It's details. Okay, in fall, leaves fall off of trees. What happens to them? They crumple up, they deteriorate. Do you find them next year? Do you find them fossilized? In this specific case, for the people that analyze this leaf, they have said that in order to get the structure, the leaves had to be swollen up. So they had to be in water and then had to be suppressed by sand, such as in a flood. There are these creatures I'll call nautiloids. Fascinating. They're found over a 100-mile stretch in the Grand Canyon. They're about 6 foot long. And what's interesting is that they're predominantly found in one direction. Now, try to explain over 100 years as creatures are dying, let's all of us just lay down in the same direction. All right? Much easier to think maybe they were caught in a current from a flood. We're swimming against it as more and more dirt came across them and buried them. Noah's Ark, I did not get to your children's museum, your children's rooms here. Do you guys have some of these cute little ark with the kids, for the kids with the animals in them? They're about falling out of the ark. This is almost a disservice to the whole ark story. Many people will look at this and say, how can all the animals fit on the ark? It's such a tiny little boat and there's millions and millions of animals. First off, for those who've been to the ark was not small. It's huge. It's bigger than a football field. How many of you guys been to the ark? All right, so we've got some people who've been there. You've seen it. You know what we're talking about, right? You know, it is huge. The other item, if you've been there, they'll talk about animals. Well, a couple items. Well, yeah, one of them is about animals themselves. Noah talks about, or in the Bible, it talks about kinds of animals, right? Kinds. So what are kinds? We got dogs here. Those are species. Now, a coyote and a wolf would be a kind of animal. A kind of animal goes into, if you have the categorization that you use for animals, either direction you can look at here. You go from kingdom, phylum, class, order, family, genus, species. Species is what everybody refers to when they talk about millions and millions of animals. You bring that categorization up 2 levels to family. Now suddenly it's less animals. You only need one kind of dog, one kind of cat, which there's a lot of species of cats out there, but you only would need one on the ark. That reduces you down to less than 10,000 kinds of animals. Very, very easy to fit on the ark. All right? So some people then will come up, what about dinosaurs? You guys that have been to the ark, you know that answer. Anybody, you can fit young and small dinosaurs on the ark. God would not have brought 2 old dinosaurs that were going to die as soon as they walked off the ark. They needed to repopulate the earth. And so, yes, very easily you could have fit the dinosaurs onto the ark. So, dinosaurs. What evidence is there for dinosaurs? You know, and especially being around after the ark. First off, you have to go back to this word dinosaur. Where did dinosaur, the word, come from? Well, it actually came about by somebody in the mid-1800s coined the word dinosaur. So what was used before that? Dragon. So are there any stories of dragons? There are lots of stories from cultures all around the world about dragons in the past. And so, of course, we know about knights, especially in their fighting dragons. Could they have been really fighting dragons? Yes, they could have been. But again, they were just like a dinosaur, big lizard, I like to sometimes say. Also, as we have pointed out here, there are many structures that have dinosaurs etched into them. This here is a temple built between 8 and 900. 8 and 900. And look at this dinosaur. You got a Stegosaurus. How does somebody come up with that design? They don't even see the fossils of a Stegosaurus. Maybe a Stegosaurus was walking around at that time. I personally think some of them had pets. I'm not sure what a Stegosaurus steak tasted like, but hey, you don't know. But Stegosauruses were walking around would be the best logical explanation for how they drew these here. And again, there's other dinosaurs on other kinds of buildings. Most recently, if some of you have followed, within the last 20 years, they have come across soft tissue that they've been able to pull out of dinosaur bones. What they mean is they'll take the dinosaur bone and they'll run through some processing. They demineralize it, and then they remove some of the calcification. After the processing, they'll have the tissue. And literally this tissue you can stretch. This is really, really cool. That isn't as important. They've now found blood cells, proteins, and other items within here, which totally destroys any theories of millions of years old. Many of these items can only get past a couple thousand years in preservation. So this is, again, within the last 20 years, and more people are looking at more bones and adding to this research. But this is really exciting they can show this. Strata layers. We're going to jump into geology as we're kind of moving things along here. So geology, strata layers, you got these layers around the world, you can see them, strata layers. Were they laid down quickly or were they laid down slowly? That'd be two questions. And if you understand where this comes from, back around the time of Darwin in the mid-1800s, a couple people observed strata layers, and they looked and say, hey, those strata layers must have taken a few thousand years. Nah, we'll give it 1 million years. There wasn't any science, no measurement. They just came up with a number. And then they talked to the fossil people and the dinosaur people, and they say, we need at least 100 million years. Okay, sounds good to us. And so they worked the two together. And that's how he came up with it. There was, that was their observational science, I'll just call it. Okay, and they had a model. Their model had to prove that the earth is millions of years old because they did not want God. They had a bias again. Now, in the strata layer, there's something called a geologic column. Many of you may have heard this. So at the lower level, the lower stratas are found the very simple life forms. And then as you go higher and higher up in the strata layers, you get the more evolved creatures until you get up to animals, more evolved animals. A few points to make on this. Basically, there is no single spot on the earth where you can dig down and find each and every one of these fossils and strata layers. They put this together based on what they have observed in spots around the world. They also don't tell you that fossils are found in different fossil strata. They want a nice, clean observation is what they put in their textbooks. Okay, so they leave out a lot of information. Down at the bottom layer, we call it the Cambrian layer, and it's one up from the Precambrian. It's called the explosion, where millions of animals came about. It's an explosion of life. An issue here is, by evolution, you should be able to see something that was younger. And in evolution, guess what? If we go into, we call transitional forms. You don't see it. Here I'm showing a trilobite. That trilobite has a very complex eye system. If you go to the next layer down, you don't see that. You don't see something that's even close to it. Trilobites, interestingly, are found not only on lower strata layers, they are found at Mount Everest. They're across the whole strata area. Don't hear that talked about. Transitional fossils. Many of you may have ran across some in your textbooks. Archaeopteryx, talked about for years and years and years. This is the animal that's going from a dinosaur or animal into a bird. This is how we get to a bird. And then people examine it closer and have determined it's nothing more than a bird. On careful examination, it is just a bird. Likewise, there's a fish called the coelacanth. And the coelacanth, again, when they looked at the fossil, they thought this is a transitional form of a fish about to step onto land. They looked at those fins and say, look at this. This is something that's caught in action. And guess what? A few years ago, they found live coelacanths still swimming around. They call it living fossils. They swim happy. They have no interest in climbing out on the land. They examine the DNA. The DNA matches modern fish. There is no evolution going on here. Again, people come up with theories. As long as there's no evidence to contradict them, they can go with it. So that's transitional fossils. Continental drift. We're going to keep moving along here. Young Earth creationists, we believe in a Pangea, right? We believe that at one time there was this giant landform existing. And it was probably pretty level. It wasn't very high. Not much for very mountains, relatively level. When we hear described at the flood that the waters from the deep burst forth. What we're talking about, great force came up and caused the continents to shift. So young Earth creationists, what we talk about is how fast did these continents spread apart? Evolutionists say millions and millions of years, and they're still moving today. I think about one direction. Think about how big the mountains are. How much force does it take to get the Himalayas? How much force does it take to get the Rockies pushed up? If you have something going very fast and it's got a lot of mass, and it crunches against another mass, it can lift it up relatively fast. It's like plowing snow. You get some snow going, you just plow it in, push it up. You got enough mass behind it, you can really push it up easy. So it can be explained, to me at least, mountain formation by fast-moving masses can be very easily explained. There's a person named John Baumgartner. He's used fancy computers, put in like 70 or more parameters, modeled it out, and he's got this, so he shows how this can all happen. It's very, very cool. Another item is at the bottom of the Grand Canyon, there's things like bent rock. When have you been able to take a rock and bend it without cracking it? This is much easier explained if you had mud. Let's say you got Play-Doh. Take some Play-Doh, you crunch it. You can get it to bend. And then it hardens. So from a flood model, you can explain bent rock. And again, bent rock is found in the Grand Canyon, along with other places around the world. Also, at the Grand Canyon, there's something called the nonconformity. Now we're getting down at the bottom, very bottom of the Grand Canyon. You got the strata layers going on, but at the bottom, there's this rough area, and then there's some rock below it. They believe that the rock below is pre-flood rock. And then what you got sitting above it is there's an area that was like a grinding of the sediments, and then you got the sediment layers packing down. Geologists that don't believe in young Earth or flood have a problem explaining this. Flood people, we have no problems explaining it. Okay, enough geology. Enough geology. Humans. I hear this talked about all the time. Evolution from ape, Australopithecine, Neanderthal, Homo erectus, human. So we hear about that. What are some facts on that? I've got a book here. This is by Jerry Bergman, along with a few other authors. He went through most of the current skeletal forms of ape to human. He wrote down what the evolutionists say. Then he examined it, and he came up with his conclusion. His conclusion was they were either of an ape kind or they were human. There is no transition. They'll talk to you about transition, but he goes in and explains how the various skeletal forms can be explained as humans with various diseases, or that it was really an ape, that they're trying to talk into something else. All right. With that being said, we'll jump into my favorite topic. My favorite topic. For those who aren't aware, but genetics is actually the area I really, really enjoy, which goes into DNA. So I've got a definition. My definition of what DNA is. You guys might want to think, what is DNA? I've got an answer for you. It's the most sophisticated computer program in existence, which gives us instructions for life. That's my definition for DNA. So what am I talking about? First off, how much DNA is there in your body? Anybody got any thoughts? Well, if you took 46 chromosomes, let's look at one cell, just one cell. You take 46 chromosomes, stretch them end to end, you get 6 feet. This is from one tiny microscopic cell, 6 feet of DNA. Oh, I was going to hold that up. All right. Anyway, how many cells are there in the body? There are 60 to 100 trillion cells in your body. And if you were able to take all the DNA in your body, attach it end for end, that would equal 67 billion miles, which is enough to stretch, you can follow this, from the Earth to Moon 140,000 times. That's how much DNA, if you stretched it out in your bodies. Now, if you try to comprehend, this also means that the ordering of the information in there must be in the right order. So before I go jumping in, I'm going to go into Rob Carter has some article on 4-dimensional DNA. And so I'm just going to give a little demonstration, a little bit of DNA. So my little model here is supposed to be a DNA strand, right? And when I tell you that it's giving instructions for life, what I'm talking about, there's something called RNA polymerase. It's a body that comes along the DNA and it reads it. So it comes along, and this is twisted. It has to unwind it, and then afterwards rewind it back up. But as it goes along, it's copying off pieces of the DNA. Then you get this copy, so to speak. It's a messenger RNA. This messenger RNA, initially they thought this goes on to proteins, but now they found out that there's other things that come in here, snip it, do other things with it. So it isn't just purely this, it's far more complicated, okay? This goes on to a ribosome. Ribosome comes in, starts going down it. It reads this 3 at a time to add on amino acids. And the amino acids are what twirl and turn into proteins. And for those who don't know protein, when I speak protein, I'm talking about molecule in your body, not a steak or chicken or anything. Okay, so this is molecular structure. Initially, they thought that there are only 22,000 proteins that were made because your DNA in all has about 22,000 genes. But now they discovered that there's like 300,000 proteins or whatever that are made, which is a whole nother problem. All right. But this is just give you an idea. So this needs to be read letter for letter without mistakes to get to here, to get to the protein to be made. So that's where I'm saying instructions. Instructions have to be read. And initially they talked about this being read one directional. That's where modern, over the last 10 years, Rob Carter and others have come up with this 4-dimensional DNA. All right. So from a 4-dimensional DNA stand, what you have is, as I was talking about, reading it in one direction to produce your protein. That's fine. 3 billion nucleotides have to be in a precise order for you to get to your proteins, for this to be read. That's amazing. What controls that? What keeps that all in order? It also can be read backwards. Now, as I say, if you understand, so on here, I'm talking about reading it one way. Another one can come along and read it backwards. The same letters. It's reading the same letters. So like reading a novel, let's say you read Grapes of Wrath. Now you start at the last page, the last letter, and you read it backwards in order, and you come up with Hamlet. That's a challenge for you guys. How can you write a novel and have it read something else backwards? All right. This is, for my mind, this is just mind-blowing. Absolutely mind. That's how brilliant our God is, that he's produced such an efficient piece of code here. Now, we are just talking about one dimension and possibly two if you're talking about going back and forth. But in the second dimension, they talk about being in a second dimension. And in that second dimension, what happens is you can go back and forth, and it will turn on and off pieces of code at other spots. What causes it to do that? How does it get controlled? That's another matter. It will skip. What I'm saying when I say skip, it will start off here, grab this little message, skip, grab this, skip, grab this, maybe every 50th or something, and produce a new protein. How does that happen? How do you get to a process like that? Some code will interfere with other code, they've discovered. It'll cause some to stop, some to begin. We call that the second dimension. Now we're getting warmed up. Let's get to the third dimension. I've been waiting to do that. I usually use this in a discussion on proteins because there's 400 lights here. And I try to explain to people that one of the smallest proteins needs to have 400 amino acids in the right order. Not only that, but it needs to be folded up. That's the smallest. You get up to 22,000 amino acids in some proteins. And they have to be in the right order. 3-dimensional DNA. What I'm talking about in 3-dimensional DNA is DNA will kind of bundle up, and then when it gets read, something comes along here and just reads this piece here and produces a protein. It'll produce a protein from here and produce a protein from here. That comes from this long stretch of DNA, needs to be folded just right to be read. How does that happen? If that's incredible. That's absolutely incredible. So you've got DNA being read in 3 dimensions. Finally, we're not quite done yet. There is time. You want to talk about something fascinating, really fascinating. So, for instance, they realized over time various things can change and read. They know within your liver the chromosomes will detect a toxin. It will manipulate, maneuver around, and come up with a concoction to produce an antitoxin. And then once your toxin is handled, it goes back to its regular shape. That's mind-blowing. That, you know, how all that operates. I mean, in biology, they're just scratching the surface on some of this stuff, which is really, really cool. How do we get there naturally? I mean, and that's where, when I talk to people about DNA and chromosomes and genetics, to me, I just don't understand how anyone can be in biology and actually believe things happen by evolution or natural selection or natural processes. I mean, it's just so complex. So, in summary, we are at the end. We're at the end. Big Bang, where did everything come from? How did it get started? Planets, moons cannot be billions of years old. There's real evidence of a flood, all right? And dinosaurs and DNA, we've just gone over, way too complex to have happened naturally. A few things to consider in this whole evolutionary challenges for evolution. How did life begin? That's a challenge. Really, how did it begin? Gender. We haven't talked about gender. That's actually an item. In natural selection, why would you even come up with gender? How do you think that that's an advantage? That's a huge problem. Why do we have a conscience? That's a problem. There should be like no evolutionary advantage for a conscience. All right. What is the origin of information? This is probably in the last 5-10 years, one of the newest things I've seen coming out in arguments, the origin of information. They realize we have information. Where did information come from? Information can create information, but can it come from nowhere? All right. Hopefully I've given you a few items to think about and a few challenges to review. Based on the data, it's much easier to believe in God, believe that God created everything, than to believe in evolution. And some people, you hear it, you have to have more faith to believe in evolution than to believe in God. In other words, it's so obvious that we've got a God out there. All right. Well, thank you very much, everyone. What was brought up is kids going off to college. As you go into college, there's a number called 77%. And they use that to say that 77% of children that are raised in the church-going kids, in their college years, doesn't mean that they're at college or not, but in their college years, 77% will step away from God. Now, there's numbers between 1/3 and 1/6 of that is from this whole ideal of Genesis. If you aren't aware, the universities, public universities, can be very hard on Christians. They will talk about you having your little Jesus security blanket with you. It's time for you to step away from your parents' thinking and grow up. They'll be very, very critical in this kind of thoughts. And so what's interesting is some of the studies have shown that kids, teens that are given creation information, creation knowledge, I forget, it's like 90% do not step away from, keep their faith. Maybe like 10% or 5% step away. So there's a huge difference for students that are shown about creation versus students who are not shown about creation. I have heard it's almost like the preteens and maybe some of the younger teens right now it's almost like they've heard a lot of the extremist views that are shown there, trying to knock against Christianity, trying to say evolution is the only way, I have heard that there's more movement and openness in the younger generation, definitely. And something, I was at another presentation where the presenter just came right out and said, well, if you're older than 50 years old, I'm not going to change your mind. He said, if you're younger, you've got an opportunity to, what I call the biases are there. You've got an opportunity. You're much more open to accept different things that you've learned. So take that for what it's worth. But I know a lot of older people. And I was one of those that I was around 50 when I went on my journey and changed the whole thing in my walk. So, but maybe I'm young at heart. I don't know. Yeah. So, other questions? Yeah, so actually, you guys have on my slide deck, at the very end of my slide deck, I have got listed publications, 2 pages of publications. I've got 2 movies I recommend. One movie I can guarantee, probably both of them, I don't know, is Genesis History. That's one of the movies that came out. They actually had a follow-up last year, was in the theaters, and Genesis Impact. I love Genesis Impact. It's really done for a younger population. They look at it's done at a museum where a docent or somebody is taking a group shows up at that museum, and they're giving a little spiel about the museum, and this guy spends his 5 minutes about evolution, everything you're going to see here, and then everybody leaves supposedly, but one woman hangs around, and she approaches, not trying to embarrass the guys, just starts challenging them, and she does it very politely, very accurately, but starts saying, you said this on this website, it says this. Can you explain that? It's done very, very well. Anyway, for movies, you're talking about movies. Like I said, on there, I've got a list of, so if you're interested, websites are on there, all the websites I use for my presentation, and movies, yeah. And so, yeah, Answers in Genesis, creation.com. For the young population, I love Genesis Apologetics, one of my favorite sites. It has everything you can download and stream, and they got handouts. And so it's lined up from kindergartners. They got material up to middle, high, to high school, to young adults, different categories for information. They can be emailed. So at the end of it, I try to put down all that information, because I know a lot of times people are looking for that kind of information. It's like myself, I'm on YouTube a lot. And of course, there's so much information that's misleading on YouTube. But at the same time, once you get into some of the proper sites, you can start going in and getting many more details on those topics. And so it's like genetics. I go to Rob Carter's site. I go to Jeanson's site. I go to a few of those. Answers in Genesis has this library that's incredible. But on YouTube, there's a lot of good videos out there. But again, you can get into sidetracked. Rob Carter, if you get into any genetics, I would really encourage you to look up Rob Carter, because he has debates with people, and how he answers them in debates, he's got dialogues going back and forth. And sometimes he admits, okay, maybe I've been wrong. Maybe I said the wrong thing. I'm sorry. But he comes in and says, okay, I'm going to tell you how you're misinterpreting what I said. And so he's, again, there's a lot of good ones. Rob Carter in genetics is definitely one of my favorites. There's, again, you can go to some of these sites at Creation or whatever. Jason Lyle and a few others, astronomers, have their theories, all right? And some of it has to do with relativity, because God stretched out the universe, stretched it all out. And so there's theories that they work as he stretched it out, how the light could be over there, over here, what we see today. There's something called a event horizon, which is an interesting, actually evolutionists and creationists talk about this. I think Humphrey is somebody that talks about it, where time doesn't exist until you reach a horizon. And then once you go past the horizon, that's when light came into form and things formed. And he goes into trying to explain light. That's one of the things that always bugged me. And then, if you look at, was Adam created as a child that grew up? Adam was created as an adult man. Do we know? God may have put one in there. So, in other words, God could have, as he stretched and placed things out, he could, like spiral, galaxies, nebula, whatever, he could be exploding these and doing this because he's God. So there is a God answer that goes beyond any real physical properties. There are people that are trying, there's 2 or 3 theories that actually try to explain it by Einstein's theories and a few other theories. So you can explore that. But there are people that do that. But I'm right in with you. Dating's the other one that used to bug me. But now if you go to some of the websites, I didn't talk about carbon dating and argon and phosphate dating. So carbon dating, do you guys understand carbon dating or not? How far back can you date something with carbon dating? Out of curiosity, how far back? We've got some people that have been to the Ark. Come on, guys. Don't remember? The very finest, if you found something the furthest back by evolutionary timelines, is like 100,000 years. And so you cannot get a dinosaur dated to be millions of years by carbon-14. It's got a half-life, it's 5,300 years or whatever. The half-life's less than 6,000 years. And so because of that, as you cut down, it would be the radiocarbon-14 nitrogen. As you bring that back, you can only get that fine with your instruments. When you get to argon and phosphate and some of these rock datings, if you look at the data, what's interesting is they're all over the charts. But like rock layer, what they've done is taken rock from like Mount St. Helens, and they've gone and sent it to various labs. They date it, and there's off by hundreds of millions of years. Hundreds of millions. So the accuracy for dating, there is, the accuracy isn't there. And the other problem for carbon-14 dating is kind of your premises. And I try to explain to people, if I had a candle sat here and it's burning, right? And you come in and then I ask you, how long has that candle been burning? Can you tell me? Now, you could do some measurements and you could say, well, it's going down at this rate. So you can figure out a rate and you could extrapolate, but you could probably extrapolate to, well, maybe it can't be ceiling high or something. But you have to know conditions. If there was more oxygen in the room, would it burn slower or faster? So if the conditions in here change, it could cause it to burn slower, faster. The same thing is with carbon-14 dating. Plants absorb the radio, and what's nitrogen, carbon-14 when it's radiated, gets absorbed into the plants, or it's in the air. Plants absorb the CO2. The CO2 then gets the plants absorb CO2, and then the CO2 is ate by animals, and they get an accumulation of the radioactive. Then when they die, it starts half-life getting removed over 6,000 years, let's say. So the issue is, first, how long were they living? How much did they absorb? How we see things absorbed today, does that match before the flood? No. We pretty much know the conditions don't. That there could have been a higher concentration given to the on absorption at the beginning. So it's some of the conditions that you lay out, how you lay out those conditions determine how you determine dating. So I don't know if that helps or not, but you have to, in other words, evolutionists assume things, and it can be shown that those assumptions are false. So, but carbon-14 and the other dating. Dating's an interesting area, but chemistry is not my strength. I'll go back to DNA. Other items. What else did I not cover? There's got to be some. Any other questions? No? You guys understand this all? Can I give a test now? Thank you, everyone. This has been awesome. I hope you enjoyed.